Hello, everybody. How are we feeling at that late stage of the conference? Is there people falling asleep here? Or I'll try not to keep you too much. I want to make this presentation as more as a discussion. So I'd really like to hear what you think, probably after the presentation, of course, but you can always try and stop me for questions. I have oh yeah, of course, I have to introduce myself. My name is Tihomir Mateev. I work at VMware at the vSphere UI division, where we work on a horizontal team that works entirely on user interfaces. I have a disclaimer before I start. This is something, the topic that I've chosen to present today is something that's more of a concept, not so much of a technology. So there's a lot of things that you could do in another way if you like to. There's also different combinations of technologies that you can use for the same purposes. So please don't accept this as the recipe for micro frontends software. It's more of what there is in the wild. And of course, how we apply it, because at VMware, we actually do have a good example of micro frontends right now. So this is my agenda for today. I will try to say a bit about micro frontends as a whole, what that means as a term. You probably are, okay, let's start with the questions. How many of you do know what microservices are? Okay, fairly few. For those of you who don't, microservices are something that is well, no longer a new concept, but a way to split your backend services into smaller parts that work together to form a larger service. Then of course, let's continue with the agenda. I'm also going to talk about the technological stack, how we can do micro frontends, and some example of micro frontends, of course. And of course, I'm going to visit the challenges that there are, and I'll leave some time for questions later. Okay, I started explaining what micro frontends are before I actually reached the slide. Sorry about this. So what exactly is micro frontends? I personally heard about micro frontends somewhere around 2016. I don't know if you know about the ThoughtWorks technology radar. That's a company that specializes in analyzing the technological stack that's out there right now. And they have this technological radar that they try to put on it all of the emerging technologies, split into several categories, and they try to give suggestions to companies in terms of whether or not they should hold on and avoid using a technology, assess a technology if it's actually going to be proper for their uses, trial, actually invest in it, or entirely adopt it if it's something really proven and would be beneficial to them. So at 2016, back then, I heard about micro frontends. That's the first time that they put the notion in their radar. It was in the assess part, so it was still not kind of very popular, and there were not too many frameworks that allowed you to do that, a few open questions. Then in 2015 and in 2016 actually, 2017 actually, they put it in the trial, and I decided to spend some more time reading on that. And I found out a lot of companies are actually adopting it. There are like tons of examples and blog posts. If you try to seek out yourself, some of this information is very widely available. There are very interesting videos on that. And so yeah, actually what is micro frontends? This is something that I've stolen from a blog. I'm really sorry about that. But it's a very good example of how architecture and team responsibility have evolved in time. Actually, a lot of these principles are still applied if you look into a smaller company, like a startup. You could see that a lot of the startups actually have this monolithic software, which is normal because they still have less code and their product is manageable in its size. So they have this, what they call the shop team. The shop team is guys that work on everything. They are good in databases, they're good in backend, they're good in frontend. Everything is kind of mixed up. You don't really have a lot of investment in architecture where you split this up. But as code grows and as the application becomes much more complicated, you tend to split it up. So here it's split first in front-end and back-end. That happens usually when you use technologies that are a bit different. Let's say you have C# for back-end, you have Node.js, or if this is a mobile app, it could be Java for let's say the Android system. So you have different specializations in your teams, and it kind of makes sense to split them up in two. And then you have this layer that you have integration between the two of them, some sort of API, probably REST. Now that works, but at a certain point, the application again grows even bigger because your company is very successful with what it does. And you have to split the backend too. You don't have a choice because it's really hard. It's hard to maintain it as a whole monolithic thing. So you do microservices. You just start popping up different servers. This could be also because you want to do a more advanced way of load balancing. For instance, your application might be under a heavy load. You have to distribute it in some way, or there are many reasons that you could switch to microservices. And then the thing that happens is that you now have a front-end team that tries to work with all the different microservices that are behind a probably aggregation layer, because you would have to have a certain single entity that you contact. By the way, do you know what is the biggest issue if you have multiple servers and your UI that's in the browser needs to access them? Could somebody speculate? Performance is also one of the things, but there's one certain specific thing that's really hard. Course. Yes, course is the answer. And that's why there's usually an aggregation layer, because the browser would force you to work with a single domain where your application is hosted. Of course, there are different solutions here. I'm going to go through them. But that's one of the reasons why you might want to have an aggregation layer. And that's what micro frontends actually are. They are the next step when you already have microservices, for one of the many reasons that I mentioned, and you want to actually have different UIs for all of them that merge together at the end as a single UI for the user. Actually, micro frontends is something that the user doesn't know exists. I'll probably prove it to you when I show you a couple of examples next. I was surprised that some of the applications that I saw were actually different parts that were merged together as a singular UI at the end. So that's a good thing. If your application is a micro frontends, has a micro frontends architecture, and nobody knows that, then you're doing a good job. What do you gain from having such a probably complicated architecture, because it requires a lot of different things? Well, for a start, and some people would not agree with me, and I'm okay with that, although they're wrong. Vertical teams, vertical teams are arguably a better way to do a job done. You want to have a single team that implements a certain functionality, because that's the best way to empower them to choose the right technologies, and also to have a very clear responsibility of what their goal is. If you have different teams managing different aspects, you always have one that's actually leading the development of the feature, and the others are kind of these helper teams. And you always have to, and there's sometimes these things, you know, in larger companies where one team says, oh, the other didn't do their job. And the first one says, well, they didn't do their job. And now it's this flame war. And when all of the team members are in the same team, they are, in fact, empowered to do this feature. And they have all that it's needed. They're not dependent on any other teams. They don't depend on other backlogs. They have their own backlog. Another thing is that it's actually self-contained. Self-contained would mean you're not really, I mentioned it just a few seconds ago, you're not really dependent on any APIs or choices made by other teams, because if you have to integrate somewhere and the only way is for you to learn this obscure, interesting new UI framework that's not very popular. That means that the whole team now needs to learn it. If they don't know it, they have to abide by it because it's like architecturally enforced on them. And they don't really have the choice to choose their own technology, which might be bad. In certain cases, they actually might have a better idea how to solve the problem with another technology, but they're still forced to use it. Isolation, that's one of the points that I really was wondering if I should leave out here, because I know that a lot of people here would say that security would not be benefited by this architecture, and they will probably be right. But if you spend a very large amount of time into security because it's very important for you, you could achieve it with micro frontends. But it will cost you a lot. It's one of the costliest things here in this slide. Reliability is something that actually I can show you. Well, not show you, but speak about, because it's in one of the next slides. Facebook are a very good example of how they've improved their reliability and their responsiveness, which is the next step, solely because they created this micro front-end architecture. Their solution, of course, is something really complicated that's, I think, still applied. But in the basis, it's actually a micro front-end architecture. So what is the technological stack? I'm not going to go into details. I'm just going to show you these technologies, and I'm going to explain a bit about them. But I want to speak more when I actually get to the examples, because with each example, I'll give you what technology is used. And it will be easier for you to understand why certain companies have decided to go in one way or the other, because these technologies, some of them can work together, others are complementary, and others can be combined at all. There are different approaches. So for instance, if you go to the browser side, you have single page applications, which is SPA. You could either have a homogeneous single page application. That means that you have one framework that you enforce on the entire company, or actually it could be infrastructure, it could be ecosystem, you could be like a vendor, software vendor of a service, SaaS service somewhere in the cloud. And if you want other people to extend your service, for instance, you might want to go with this homogeneous SPA. That means that you say to your clients, we use Angular, or we use React, or we use Vue.js, and everybody has to go with that. Of course, the plus side to this is that you have complete control of how your site looks, and it's arguably simpler to put the whole thing together because it's made out of similar parts. But of course, you have the problem that I mentioned a few moments ago, that different teams can't actually use their different technologies that they like or think are better. Of course, there's the heterogeneous SPA. That is a really hard thing to do, by the way. I tried to look into this. There's this single SPA framework. You could try and look at GitHub. It actually argues that it could put together a single application made out of different, let's say, Angular, React. I think actually they had Angular and React in their example. It is possible, of course. it comes with a great cost because these frameworks are not made to work together. And of course, one of the obvious things is one of the frameworks needs to be working on top of the other. You can't have Angular's routing and React's routing working together. You have to put one on top of the other in order to make the application work. Iframes are something that's been there for a long time. I know that a lot of people frown upon iframes, and rightly so, because it's a dubious technology. It had a lot of issues before. It has a lot of issues right now, but it also has a lot of benefits, and I'll show you later why. Web components is something really interesting. It's very fresh. So fresh that actually Shadow DOM is not supported by any browser, which is kind of fresh. Service workers are actually supported by the majority of the browsers. But these are very interesting technologies because they allow you to do native stuff in the browser. You don't have to use, well, right now you have to use a shim because there's no support, but at some point you would actually be able to create your native application only relying on the Web Components API. On the backend side, there's a variety of things, and I only mentioned some of them. Edge-side includes and server-side includes are mostly the same thing. One technology is newer than the other, and one is applied on a very popular reverse proxy like Nginx, and the other is applied on a bit more newer and not that proven, I guess, application such as Varnish. Any other type of reverse proxy is also very popular for these cases. There's a lot of custom implementations here, and there's a reason to that. There's still not many publicly widely available mechanisms to do the stitching on the backside, besides edge-side includes and server-side includes. Do you know what server-side includes are? Or edge-side includes? Show of hands. I'm not going to ask. I'm going to explain it. You just say yes. No? Wow. Well, I didn't know too. It's a way to build up your application in the backend by saying your server, let's say the Varnish server, is the thing that you contact from your browser, and in your application, in the HTML, you put special tags that say this application is made out of these and these and these pages, let's say 5 pages. And when the request is made, the Varnish server actually takes care of building up the application itself. So it's doing the job for you, and also avoiding CORS as a separate step, because you would still use one source for your information. Server-side includes is the same thing. It's actually having the same tags. It's just a bit less, oh, it's not new. There are things that were fixed by edge-side includes. I would answer questions later on details if you are interested in any of these. I want to show you some examples first. So these are the examples. By no means these are the best examples. These are the examples that were easier to find on the internet. And I start with the most popular one because probably a lot of you have Facebook. And Facebook have this very interesting framework that they've created. It's actually, this could be a topic for a whole talk, and still you will not be able to grasp how many things they've fixed here. Facebook created this big pipe framework mainly to speed up loading of their application, because they found out at some point that there is this thing that when you start downloading, when a lot of users start making calls to their backend, what happens is that they have these large periods of inactivity that is slowing things down. So you make a request to the backend, in the same time the browser doesn't do anything. So now the backend tries to build up some stuff. It builds your web application. Even if it's in chunks, it still takes some time. It gives you back some information. Then the browser starts rendering it, and at the same time the backend doesn't do anything. So these steps that the rendering of the application is taken, they are not optimal. They're not really taking the best of the technology that we right now have. So what they did instead is they started to, first of all, they started to chunk the entire request in HTTP 1.1. There is an option for you to start putting information, flushing information in the buffer in chunks. That means that you receive on the other hand, on the other side in the browser, you receive the information in smaller amounts, and the browser could start working on something before the whole data has received, the whole page actually being rendered. And so you have this chunked data, but that's not enough. What they do is they start to split up the whole page. You can see here, and that's from their blog, so I assume it's right, and I'm not making stuff up. All of these rectangular, blue rectangulars here are actually different, what they call pagelets, or was it facelets? Something like smaller pieces of the page. And what happens is when you first start loading the application, each of these parts begins at a certain level of processing, and every new part is offset by one step. So at any moment, any part of the application, whether that's the front end or the back end, is working on one of them. All the time, their server and your browser are working to visualize your screen, and there is no way, point at which your browser is waiting for something or the server is waiting for something. The whole time there's processing being done. Of course, there's a lot of other things that are happening behind the screens. They have this skeleton views, which is a very good concept of visualizing the component first with mock data. Well, not mock data, but these blurred out things, if you've seen it. And only then actually requesting the actual data so that the user is able to quickly see the application up front, and then different parts of the application start popping up. All the information comes at different moments. And it's actually quite faster. For Chrome, it's, I think, twice or more faster than using a standard approach, the conventional way of displaying the page. It also allows you to have the vertical teams that I talked about. So for instance, the team that's taking care of, let's say, your messages on top, or the news feed, or the applications. These are all different teams that have their own different backlog. They just plug into this page, and they have nothing to do with the other teams. Well, probably some APIs that use, but nothing else. And that's for Facebook. Now, a very interesting framework, and I only put this here because I find it very amusing how much this company called Zalando has actually built up themselves. They like the idea of BigPipe. BigPipe, by the way, is not open source. There's a lot of different implementations, even for Node.js, for Java, for PHP. There's a very, I think, mature implementation for PHP. But it's not actually open source, so a lot of people got really excited by what Facebook did, and one of them is the Zalando team. They created this, it's probably a suite of different parts in order to replicate that and take it even one step further. What they do is they have this skipper thing, which is the router, that reads from a route config API. So all of the APIs that are standing on the left or on the right, these are like containers that all of the teams that create the UI actually contact to push their data. So imagine creating a new UI for this entire ecosystem. What you would have to do is you would have to create first the routes for your pages, which is probably something like dash my new functionality dash page one. And then you'd have to also push your UI in the layout storage, which is Quilt. And what happens when you request a page in their application, it's pretty interesting. The router acts as a reverse proxy. It takes all of the different parts that the route you specified has, because a certain route might have like 5 or 7 pages in it, different teams contributing different functionalities. Then it just binds them together. But before that, before binding them together and returning them to the user, what happens is that the tower framework, which is the layout service, actually reads a JSON configuration of the UI and then reads the UI components that are involved from this shaker service. And these are all fragments. That's how they call the different pages or different fragments. And it binds them together in this tower service. It binds the whole thing, gives it to the skipper, and the skipper returns it to the browser. So it's a lot of components working together to solve several different issues. So one is the fact that you have cores, so you can't actually call different servers in your browser. You have to have a single UI representation. You can't have teams developing something on a framework that doesn't work with the framework of the other team. So imagine having React and Angular and different CSS files and different styling frameworks. One could use like Bootstrap, another could use a different CSS and JavaScript. And to solve this complexity, they created this very complex CMS system. If you know what CMS is, content management systems. Actually, the teams do very little programming outside of the JSON and the routing. They've narrowed down the technology to a very simple set of things, which again is something that might do a job for them, so it's good. Another example that I've come to is the Allegro opbox. Here is this Varnish server that I mentioned. It's the server-side includes server. It does this binding on the backend for you, getting all the different pages and putting them together. Also, it has a very complicated functionality that caches information. So you have here a very serious performance boost from the fact that you have this caching, because you might have many different users trying to access a certain set of functionalities, and when they are cached, you don't have to build them again. It's easier. And then, of course, in the UI, they still need to have a solution for having the same CSS, the same user experience. So what they do is they have different versions of React. This was interesting for me. So one team could work on an older version of React. The other team could work on a newer version of React. They were still all binded to React. There were no other, not versions, but frameworks involved. However, they were still able to do that, which is good because it allows you to, let's say, do a new version of React for the new component and don't have to spend a lot of investment to upgrade your previous components. Again, the result was a bit more something like CMS because they've simplified it a lot for the developers of new pages. It was mostly REST and JSON at the end, so you don't even have to write HTML or JavaScript. And these are all of the other examples. I'll briefly mention some of them. I would very strongly recommend that you go to YouTube and write down Gut Frage. I'm not sure how this is, probably in German. I'm not sure how to pronounce it. That's the one on the center on the right. They have a very entertaining talk about the whole process that they run into when they build their application. They kind of tried everything. They tried the server-side includes, they tried the client-side includes, they tried different app shells, whatever I mentioned here, they tried it all. And they ended up with something interesting and complex. It was the app shell principle is the idea of having, does anybody know what app shell is? App shell, that's the second here line. No. So app shells are basically, that's the idea of having your browser build up the page itself, doing different stuff in the backend. So you get a initial version of your page, and then it starts processing different things. It starts contacting services and builds up the whole skeleton of the screen, but by itself. So you don't do it on the back end, you do it on the front end with some help from the back end. It's a bit complex, and it depends on the actual implementation. It's not actually a framework, it's a concept of building an application. So app shells are really interesting, but very customized right now in terms of how they work. Spotify is a very good example, by the way. I don't know how many of you use Spotify. Their application, even that's in your pocket if you have a phone with Spotify, it's actually a web application. I didn't know if you know that. They do have their vertical squads. Their teams are called squads. And every squad is responsible for a certain part of their UI, which is a smaller version of the whole UI. And they pack this up for desktop, for mobile, whatever you decide. And they glue it up together with frames. Actually, all of the different parts of an application, of their application, are different frames. And they communicate between each other with post messages. Post message is an API in the browser where a frame could post a message to the parent or a different frame. And you subscribe to messages and you post messages, and that's how they communicate, asynchronously, of course. One of the interesting things in their talk was that because they're doing these frames, the different parts of the UI are so well contained that they could actually, when you install Spotify, you get a certain version of the product at a certain point, but at any time they could actually push a new UI to you. They could just push the, let's say, your friends list, although there's no such feature there. But let's say you had such a feature, they could actually push the whole feature to you, and it would just re-render the new thing. It's really easy to push a critical update, let's say. They also use it for their internal app reviews. When they send, let's say, to their executives a new version, they just say, okay, give me your account. I'll just push the new UI to you, and you have it. It's really interesting. They use Glue. Glue is initially a fork of Bootstrap, but that's their way of having UX consistency. Otherwise, all the different parts would look different. Klarna, I only had very little information about Klarna, a discussion in a forum or something. I don't really have the whole picture, but it was interesting to see the different issues that they run into while building a micro frontends application. For instance, they tried to nest frames. They also used frames, but they decided not to. They couldn't nest frames more than 2 levels. So when you have a frame with a frame with a frame, certain browsers, and I'm totally not saying Internet Explorer, were acting really weird or stopped working at all. So yeah, it was interesting to see that these are actual problems that they had. Another issue was size and duplication. It was amazing how many times their application grew, because in each frame you have to load your application. And probably if you use Angular and you use tree shaking and you're really, really optimized, and you won't have this problem. But with other frameworks, such as the ones that they used, you have to actually download for each frame the same CSS resources, the same JavaScript libraries over and over again. And if that's like 5 frames, then that's 5 the times that your normal application would otherwise download. Autoscout also have a very interesting talk in, I think it was YouTube. By the way, I'm going to upload these slides to SlideShare, and there's links on each slide if you'd like to follow them. Autoscout had a Varnish solution initially. Varnish was using this edge side includes, and these guys were really not happy with this decision. They said that it was really slow. They couldn't optimize it to work with caching really good. So what they did is they got Nginx, they put this page speed module, which is something that I don't know and I can't talk about, sorry. You could read about it. But they solved all of their problems because I don't know if you know, but Autoscout is one of the most visited pages in Europe. People just like buying cars, I guess. And they had a lot of load on their servers. They had to solve this issue. IKEA also have a very nice presentation from their, I think it was their architect, the architect of their website. He has a lot of things in this article where he compares different technologies, such as they were considering using either client-side includes or edge-side includes. Client-side includes are what you would do manually with JavaScript to build up the application on the browser, where, you know, as I said, edge-side includes do it on the back end. One of the issues that he mentioned and they had is that with client-side includes, search engine optimization was really bad. Well, at that point, this may have changed because when a bot, when a crawler tries to index your page, it's not actually built up. The bot would have to build the page up with the JavaScript that you put there. So some of them were advanced enough to do that, some not, and to some extent. So client-side includes are a bit tricky with search engine optimization. And IKEA is a site that needs that. I mean, when you type in new bedroom, you would want to see IKEA first. I would want to. So what is interesting about our solution? It's not that different, of course. It is mostly the same thing. VMware has a product, the vSphere client. We want to embed in it different UIs from different backends, most notably from partners. And we want to have it in a performant and secure way, especially with VMC present, because I don't know if you know, but right now the client is used also for the VMware cloud, where a lot of different tenants share the same environment. We use a reverse proxy. That's the only way that you could solve the issue with cross-site scripting. We tried to use Shadow DOM, and we will continue trying until it's actually supported in the browsers. Shadow DOM is something that will allow you to isolate a whole part of the tree, the DOM tree, so that it doesn't interact with the other parts. That will allow us to just plug a page somewhere and say that's a shadow DOM, and no CSS would be affected even if they include some weird CSS that breaks our CSS. Also, it would actually isolate the JavaScript calls between the different parts, let's say the plugin and the actual UI. We use Clarity. Clarity is VMware's open source UX framework. That's what we recommend to every partner to use because it would allow you to have the same look and feel. It's based on Angular. And we use the post messages API where we actually expose, because we use frames right now. Shadow DOM is not really doing the job of isolating. The post message API actually allows the plugin to communicate with the other parts of the UI, where we expose an SDK and allow them to communicate with us. Why not use it? Oh, there's a lot of reasons why not to use it. I'll try to cover them one by one, but they're not all here. These are the things that I think are most important. One, of course, I put this morning as the first one because I realized that most of the applications right now really rely on search engine optimization. So if your application actually relies on SEO, you would have to really think how to implement it. You'd have to be sure that different crawlers would be able to index your pages. Otherwise, the whole design of your application would be its downfall. Design consistency is really something problematic. You know, you do break the things to make them easier for different teams to work together, to work on a certain feature, but then you have integration, and integration is always a painful part. You saw that a lot of the solutions that I described actually solved it in a very brutal way where you just say, we do the integration and you don't have to take care of it, but you also don't have any way to change the technology or influence architecture. Duplication of both code and libraries, really hard to do. Even if you do right now the best practices for an Angular app and do like the very minimum set of Angular app single page application, that's the JavaScript and the vendor, the several, depending on if you use Webpack for a loader, even then you would have duplicated code in different parts of your UI. Unless you do something like IKEA. IKEA do that, they have only 2 imports for CSS and JavaScript. Nobody is allowed to include CSS and JavaScript in their pages. They could change this, but they could not add new ones. And they only add different fragments in the different pages. So that kind of takes care of that, but it's still a brutal decision. You don't have really much freedom to change whatever you want. And of course, let's not forget about Internet Explorer. It's actually, I'm joking. All of the browsers, all the different browsers have limitations. The iframe issue was not limited to Internet Explorer. Neither is the support for web components, where different browsers for different operating systems, for different applications, whatever, they have different support. So it's not uniform. You don't have it all done for you. As I mentioned before, security is really, it's a huge issue. It's a huge issue because you could have the following situation. You could have a multi-page, micro front-ends app, and one of your front ends could be this evil plugin from a competitor company that just plugged their code there. And when you serve them from the same IP, not IP address, but address in the internet, it's really easy for them to just steal your cookie, impersonate you, do stuff with your access your DOM because it's a parent DOM and just say, okay, I just want to make it look bad or make it blue. So security is hard, but could be achieved. And performance, it's weird because you could actually influence it in a good way because it's loaded in different chunks, so different parts of your application come up in different speed. But in the same time, it's really hard to measure when your application is actually up and working and how the different parts of your UI are influencing the load of the entire application. So you could have a malicious, again, plugin or just badly written one, and it could be really slow. And you know that the browser has a certain limit of HTTP connections. So if it just exhausts all of the connections, the whole application stops working. So it could be it could be good for your performance. It could be bad, depending on how you do it. And of course, now is a good time for questions, if you have any. Don't be scared. Yep.
Yeah. Watching all of this, it's cool. Just wondering, where do you see this thing going with lazy loading components instead of trying to, use iframes?
Yeah, that's a good question. Lazy loading is a part of actually this architecture. Even more black box components, because if you black box a component with or without some of these web components APIs, and it's a good way, but you still bind yourself with a single technology. It's depending on the architecture, of course. But let's say you have a React application. If you want to black box a component and just lazy load it, all your teams have to do the same thing. They have to use React. But it's a good question.
Yeah, but you still, avoid the problem of having to load big bundles of, different libraries.
You still have to load them, just lazily.
No, I mean, one of the issues was that you were, bundling all of the different frameworks into different applications and then trying to load them, which increase the bundle size.
Yeah, sure.
This thing, but this is, I'm not trying to solve this problem, just asking.
No. That's really nice, and it's exactly what some of the solutions actually did. I just didn't mention it. It's a lot of information there, but yeah, they do that. They start with some chunks. They do a skeleton view where you just have the view and it's loaded then in the background, so it continues to load after you see the first results. That's probably the best solution. Yes. Thank you. Anyone else? Don't be shy. Oh no. They were before us. I blame you. So if nobody has any more questions, these are my contacts. I'll be happy to hear from you if you have any comments. And thank you.